angles formed by them when they're cut by a transversal. Well, all right. So when we're going through this, all right, remember when it comes to these types of problems, you got like a 50-50 shot of getting the relationship correct. Because remember, depending on the relationship, the angles are either going to be congruent or supplementary, meaning they add to 180. All right. So first things first, we're just going to label the ones that they gave us. So angle 2 is 58, angle 13 is 111. So angle 2 is 58, angle 13 is 111. And I'm going to label them over here because they already gave them to us. They also said that X is parallel to M. So line X, which is right here, is parallel to line M. So I'm just going to mark these with my arrow tick marks. And line Z is parallel to line Y. So with 2 arrow tick marks, I'm going to mark these 2. Just so I know where my parallel lines are. So whenever you start a problem like this, that's what you should do. Use all the information that they give you and mark the picture accordingly. All right. Now, I'm just going to take volunteers. Someone tell me one angle that they could find and how they found it. And Bradley. Say one more time. Right. 11 is 58 because it's vertical to angle 2. All right, someone else. Eli. Angle, which one? Angle 1 is 122, you said? Good. And how do you know that? It's supplementary to angle 2. And what relationship is it specifically? LP. Linear pair. All right. So angle 1 is 122. All right. Reynolds, what you got? Right. 12 is 122 degrees because it's vertical to angle 1. All right. Someone else. Lucas. Right. Angle 4 is vertical to 13, so it's also 111 degrees. Someone else. Say it one more time. Right. 3 is 69, and then supplementary to, you can either say 13 or 4, it goes either way. They're linear pairs. All right, someone else. 1469 because it's vertical to 3. Good. All right, someone else. So 8 is 58 because what? All right, so what theorem is that? So he's saying 2 and 8. What's the relationship between 2 and 8? Nope. They're corresponding. All right. They're technically in the same spot. They're both on top of their individual line. They're both on the right side of the transversal. All right. So these are corresponding, which makes them congruent. All right. Someone else. 5 is 58 because it's vertical to 8. Good. All right, someone else.
18 is 122 because it's like.
You're right, it's 122, but what's the relationship?
Corresponding.
It's corresponding. Good. And it's hard to tell, but remember, X and M are also parallel, so in this case, Y is a transversal. All right, so these two are technically corresponding. All right, so what else? 1658 Y. It's corresponding to what angle? Angle 2. Good. You could have also said the linear pair to 18. That would have also worked. All right, someone else. Right, 10 is 6. Okay, so 10's not quite corresponding to 3. Oh, wait, yes. Yeah, it is. Yeah, it is. I'm crazy. Okay. Yeah, it's corresponding. You're right. Second guess myself there. Yeah, so 10 is 69 degrees because it is corresponding to 3. All right, someone else. 17 is 122 because it's vertical to 18. Good. All right, what else? Nineteen is 58 because it's corresponding to 11. Good. That is what you said, right? Oh, vertical angle. You know what? Same thing. They're both congruent. So yes, vertical angle to 16 corresponding to 11. You could have said either one of those because apparently I am deaf. All right, someone else. Someone who hasn't talked yet. Someone who hasn't talked yet.
9 is 53 because it's supplementary to 10.
Right. So 9, you can say it's 53 because if you look, all three of those angles are on a straight line. You got 2 of 3. So if you add those up, subtract from 180, you get 53. All right, someone else who has not talked yet. Right, 6 would be 53 because it's a vertical line. What's another way you could have found 6? So that's a way you can do it, but here's why we can't divide by 2. The main reason is because we have no proof angle T is angle bisector. All right, it may look like it, but unless they flat out say T bisects angle 6, 7, we can't assume that. All right, but that's a good thought. If that was an angle bisector, that would definitely be true. But in this case, we would have to assume supplementary. Or there's another way we could have done it. What's the other way? Right. So, if you notice, there's a triangle right here. We had 2 of the angles, so we could have used triangle sum theorem to find angle 6 as well. That's another way you could have done it. So it's kind of a combination of parallel line theorems and triangle theorems. Okay? Another one, what you got? Right, 15 is 53 because you see the small triangle right here. Out of these 2 angles, subtract from 180. That's what you get. All right, Shelby, you get the last one. You got. Right. So angle 769 is vertical to 10. You could have also said it's supplementary to 5 and 6, however you wanted to put it. All right. So these are what I call big pictures. It's where I give you like one or two angles, so basically enough to find the rest of the angles. But basically, you're not going to find it in order. More often than not, you're not. You're just going to go through and you're just going to mark whichever ones you can find automatically based off of the different theorems. All right. Any questions on that first one? All right. So these last two. First off, with number one, what theorem is going on here? It's actually a triangle theorem. So technically it's asking us to find angle YED. So we're finding this angle right here. And just so we know, 6x plus 1 goes with the D, 25 goes with angle C. So what theorem, we talked about it, or I talked about it in a video earlier this week. Say one more time. It's the exterior angle theorem. So what does the exterior angle theorem state? The what? So you're partially there. So yeah, it has something to do with the interior angles equaling the exterior angle, but what part specifically? Right, so the two non-adjacent interior angles, the one that's not immediately next to the exterior angle, if you add them up, it'll equal the exterior. So how would I set up my equation to find x? Someone started to say it. Set them equal to each other. So we're going to add the 25 to 6x plus 1 and set equal to 8x plus 6. All right. So I want to do this quickly because I know y'all can solve a multi-step equation. So this will be 6x plus 26 equals 8x plus 6. Subtract the 6x to one side, the 6 to the other side. So we get 20 is equal to 2x. So x is equal to 10. Now, it asks us to find angle YED. So that's that purple angle. So how do I find that angle measure? Plug it back in for x. So I'm going to have 8 times 10 plus 6. And that'll give me 86 degrees. So my exterior angle would be 86 degrees. Now, if that's the case, what would this angle have to be? Celia. It would have to be 61. All right, you could have either found that by plugging it back in for x, or you could have just done 86 minus 25. Because remember, these two have to add up to this one. All right, number 2 is also exterior angle theorem. So you would do the exact same thing. You would add up these two angles, set it equal to this one. All right, so this will be 40 plus minus 5 plus 19x is equal to 26x. So this would be 35 plus 19x is equal to 26x. So 35 is equal to 7x. Divide both sides by 7. X is equal to 5. Now, it asked me to find angle VEF. So VEF, it's this angle right here. So I plug it back in. So I do 26 times 5. And what would I get? 130. Good. And just for funsies, if that has to be 130, that means this angle has to be. So this angle has to be what? If this one's 130 and this one's 40? 90. 130 minus 40 is 90. Again, I didn't ask you to do that. If you just found this part, you're golden. But, you know, just to keep the brain juices flowing. How that works. All right. So today we're going back into triangle land, but now we're going to be talking specifically about how to determine if two triangles are congruent if we're given certain properties about it. All right. So we know that congruent polygons of any type mean what? So remember, a polygon is just a name for another type of shape. So Clark, what's a congruent polygon? Same shape, same size. All right. So we are going to show that triangles are congruent to each other based off the specific properties. Now we're splitting this up into 2 days. So today we're learning about SSS and SAS, and I'm going to explain in just a second what that means. So turn to the next page of your packet. All right. So quick review from Unit 1. What characteristics in translations, rotations, and reflections share? They're rigid motions. They also produce what? So because they're rigid motions, what happens to the image? They're the same or they're congruent figures. So they're rigid motions that produce congruent figures. All right. So congruent polygons in specifically are two congruent polygons. All parts of the polygon are congruent to the corresponding parts of the other polygon. The corresponding parts include both the sides and the angles. Now, why would I say corresponding and not say the same parts? Why would I say corresponding instead of the same parts? Why do you think that? They can be in different locations. So, for example, think about rotations. Sometimes when we rotate a figure, its orientation would look different, but it would still be a congruent figure. All right? It's like, say, if we had, let's say we have a right triangle, let's call it ABC. And we knew that, we knew that. And let's say I had another one, just turned this way. All right, and we call it DEF. Is it not true that these two would be congruent to each other? Would these two triangles be congruent to each other? Yeah. We got the three sides here. All right. We know that it's right angles. The only difference is that the orientation of it changed. All right. So if I had to say the corresponding parts here, side DE would correspond to side AB. AC would correspond to EF, BC, DF. Yes, ma'am. So,
I didn't know if the
I honestly just kind of pulled it out my butt as an example. So I just labeled that as the right angle. So on specific examples, it'd be pretty obvious. But in this case, just for example's sake, that's why I did it. All right. So given triangle CAT or CAT, and we know it's congruent to triangle DOG. So let's think about corresponding parts here. Let's talk about the sides and the angles. Let's go through the sides first. Someone tell me one set of sides that have to be congruent if these two triangles are congruent. Say one more time. So that's the angles. I'm talking sides right now. You're okay. CA. Yeah, CA and DO. All right. So these two would be congruent. Now, little trick of the trade. So this kind of corresponds to what we just said about C and D being congruent. All right. Make sure that when you write out congruent segments, you're writing them in the same order based off of the corresponding. So for example, since C and D, we know those be congruent angles later on. If we write CA, we have to start with the corresponding part to C, which is D. All right, so DO. So what you said is actually very, very good because that kind of led into that conversation. All right. So what's another set of corresponding sides? AT and OG. So I'm going to mark these with 2 ticks. So AT is congruent to OG. There's one more. What is it? CT and DG. I want to mark them with 3 ticks. Now, the reason I'm using different number of ticks is because we don't know if any sides within one triangle are congruent. So we have to assume it's scalene, meaning all sides are different sizes. All right. So we would say CT is congruent to DG. All right. Now angles. So we already know that C is congruent to D, because that was already said. So angle C is congruent to angle D. What else? With another set of corresponding angles. A and which one? A and O. Good. So I'm going to mark this one with 2 ticks because we don't know if C is congruent to A or not. So we have to assume they're not. So angle A is congruent to angle O, which leaves us with T and G left. So I'm going to mark this one with 3 ticks. So angle T is congruent to angle G. So these are our congruent sides. These are our congruent angles. And remember, unless it states that sides within the actual singular triangle are congruent or angles within the singular triangle are congruent, unless it flat out states that, assume that they're not. Right? It's like innocent until proven guilty. It's exactly like that. All right. We can't prove it's guilty of being congruent until we have enough facts. All right. So again, with congruent, all corresponding sides and angles have the same measure. So sides and angles, same measure. Congruent polygons, just to repeat it, all polygons which are all corresponding sides and angles are congruent. Now, corresponding parts of the triangle are the sides and angles that are in the same spot of the triangle. So it's like when we were talking about the corresponding theorem with parallel lines, same spot, different line, same thing with the triangle, same spot, different triangle. All right. Now, this is pretty important. Corresponding parts of congruent triangles are congruent. You will see this again when we do proofs, but just know that this abbreviation is CCP. No, it's CPCTC. All right. So, especially when we start doing proofs, you will see CPCTC come back to haunt you. But just know it just means corresponding parts of congruent triangles are congruent. And that's a mouthful. That's why we abbreviate it. All right. Too many C's in there. Well, then like tongue twister. Now, if two triangles are congruent, then the corresponding sides and corresponding angles are congruent. So that's essentially what CPCTC means. If we know that the two triangles are congruent, that means their corresponding parts are congruent. And again, that will come back to haunt you guys when we do proofs next week. Now, let's actually talk about the different types. All right. All right. So, for example, here, it's just trying to find the corresponding part. So, what would be the corresponding part to line FD? So, right here, what would be the corresponding side in the other triangle to line FD? IK, good. Now, why do you say IK and not KI? Right, we started with F, and we note F has that 3-tick angle. And we have to start with the 3-tick over here, so I to K. All right. So it's angle, not angle, side IK. Now, this also comes in handy when we name triangles. So when we name triangles, we gotta name them based off of their corresponding parts. And just like with sides, if we start with one and then go to the next and the next, we have to go in the right order. So if they say I, J, K, that's the triangle they're looking at. What do we name this triangle based off of corresponding parts? S, T, R. That's right. So because we started at I, so we go along the 3-tick, go to J, go along the 1-tick, so we get to K. That's exactly what we're going to do here. All right. Same thing with angles. I, J, K. So we have S, T, R. Now, instead of having to write out the word triangle, a lot of times you'll see it as they draw a little triangle and then they write the 3 letters. So S, T, R. So if you ever see this, a little triangle symbol next to 3 letters, that's the name of the triangle. All right, that's the shorthand for it. Because like I said yesterday, mathematicians, we don't like writing out full words if we can help it. All right, we shorthand a lot of stuff. All right. So with this one, we know that triangle JIK is congruent to triangle JCD. So it wants us to mark all of the corresponding and congruent sides and angles. So since this picture is a little hard to tell what's what, that's when you look at the name specifically. All right. That kind of tells you what corresponds with what. All right. So let's look at the angles first. What to someone Someone raise your hand and tell me two angles that correspond with each other. Danny. K and D. All right, you're in the same spot as each other, so we're assuming K is congruent to D. So K is congruent to D. What's another set? C and I. Good. So C and I. There's one more. J and J. I heard it. Good. So angle J. Notice how they have what relationship to each other? They're vertical. All right. So technically they are the same angle. All right. But if we want to be specific, this would be angle IJK. This will be angle CJP. All right, we want to be specific with it. Now, since we have marked our angles, it's a little easier to tell where the corresponding sides are. So, someone tell me one set of corresponding sides. CJ and JI. All right. So they are corresponding sides, but remember, make sure you do CJ, you start with I. So it's IJ. All right. So IJ and CJ are congruent. What's another set? CD and IK. Good. Those are also congruent. Which leaves us with KJ and DJ as our other sets. So guys, if they ever ask you to mark where all the corresponding sides are, and all they tell you is that the two triangles are congruent, start with the angles because that's the easiest part. Because literally whatever order it's in, it's literally telling you, okay, I is corresponding to C, K is corresponding to D, and so on and so forth. All right, and then the sides come easier after that. So it's a little easier to see once you mark the angles. All right. So let's do one or two of these. You don't have to write out all the names that are congruent to each other. As long as you know that all these tick marks mean congruency, and you know that if I did ask you to state them, you would make sure that list them in the corresponding order. I'm fine with that. All right, just for time's sake, because I know you guys know they're congruent. Now, if you want to write them out just for like your note's sake, that's fine. All right, so let's do one of these together. So it's saying that triangle ABC is congruent to triangle DEF. So I'm just going to draw two triangles right here. A, B, C. Bless you. And D, E, F. All right. And for easy sake, I'm going to draw them where the corresponding sides are already facing the same orientation, just so I don't have to do too much thinking with it. All right. Now they give us a bunch of information that we need to label. So they said AB is 7, BC is 9, AC is 11 plus X. They didn't say DF is 3X minus 13. And DE is 2Y minus 5. Now, it asks us to find what X and Y would be. And we're also going to take it a step further and figure out what the side lengths are going to be. Now, some of them we should already know. So, based off the triangle ABC being congruent to DEF, what are my corresponding sides? A, B, and D, E are congruent. What else? B, C, and which? E, F. And then that leaves A, C, and D, F. All right. So we can conclude that if BC is equal to 9, EF also has to be what? If they're congruent. 9. What about DE? We know that's equal to 7. Now, that's not what Y is equal to. That's just what the side should be equal to. And then DF and AC, we don't know just yet. All right. So let's solve for Y first, because that one's pretty straightforward. How would I set up an equation to solve for Y? Right, 2y minus 5 and set equal to 7, because we know since A, B, and D, E are congruent, and A, B is equal to 7, that means this side also has to be equal to 7. All right, we just don't know what the y is. So if we solve it very quickly, we would get 2y equal to 12, so y is equal to 6. And if we took a minute to plug that back in, just check to make sure we get 7. 2 times 6 is 12, minus 5 is 7. So we're good. Now, how would I figure out what x is? Right. So since these two sides are congruent, we just set them equal to each other, solve for x. So we get 11 plus x is equal to 3x minus 13. So move the x and the 3's around. So move the x's and the constants around, and I get 24. So that's 11 plus 13 is equal to 2x. So that's 3x minus x. Divide by 2, 12 is equal to x. So if 12 is equal to x, what's the length of AC and DF? If I plugged it back in, it would be 23. All right. My suggestion is if we know that they're congruent, plug it back into the easiest one, which would be AC. All right. So 12 plus 11 is 23. So both of these would have to be 23. All right. Now, the next example, I'm not going to do it just because for time's sake, but it's pretty much the exact same thing as this one, but with angles. All right, so find the corresponding angles, set whatever you need to equal to each other. All right. You guys need me to go over this one? Are you good? All right, moving on. All right. Now we're starting to get into the postulates. All right. So there are several congruency postulates that we use in this class to determine if two triangles are congruent without them flat out saying that they're congruent. All right. So again, just to know that how we can prove that two triangles are congruent if all the angles, all three angles are congruent and all three sides are congruent. Now, that means that we have 6 different pairs of congruency that we could have. So 3 pairs of sides that can be congruent, 3 pairs of angles that can be congruent. All right. Now, we're going to talk about 2 postulates today. All right. These postulates allow us to only need to show 3 pairs that are congruent, whether they be a set of angles, a set of sides, or a mix of both, but they have to be in a specific order. So that's where knowing where corresponding pairs are is very, very important. All right, when it comes to this order. So the first postulate is the SSS postulate. All right. This stands for side, side, side. All right. Guys, these postulates are like the abbreviations are literally very literal. So SSS, side, side, side. So it states that if three sides of one triangle are congruent, to three sides of another triangle, then the two triangles are congruent. All right, so for example, let's look at this first one. Okay, this is where we play the matching game. All right, so remember, the number of ticks dictates which sides are congruent. So this side says one tick would be congruent to this side, this one with two would be congruent to this side, this one with three would be congruent to this side. Now, based off of how triangles are, if you have three congruent sides, automatically those angles will be the same. Because if you think about it, if you connected those sides like in real life, like say I connected these markers, you know they're different sizes, so I just connected them. All right. No matter what orientation or order I put these markers in, they'll always form the same angles. All right. So that's why these are congruent. So all sides are congruent to the other three sides. Now, another way that you'll see side, side, side may be like this. So this is technically side, side, side. But what's going on between these two triangles? What do you notice? They're adjacent, so they're connected to each other. But since they're adjacent, that means they share a what? They share a side. So why can I say that this side is congruent to itself? It's the same side. All right. Logically speaking, if it's the same side, it's obviously congruent to itself. Now we're going to learn in just a second what that property is called. But that third side is shared, so it must be congruent to itself. All right, so even though we only see two sides that are marked as congruent, since it shares that side, we can assume that it's, the same side, it's congruent to itself. All right, any questions on SAS? Not SAS, SSS. All right. Then we got SAS. So this one stands for side angle side. Now, this is where you have to be careful. All right, this is so side, side, side. Right now, order doesn't matter. So side, side, side is the easiest because as long as they're marked correctly, you don't have to worry about the order. Side angle side, that's when you have to start worrying about order. All right. So what it's saying is that if two sides and the included angle, all right, of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. Now, included angle means the angle formed by the two sides. So it's the angle formed by the two given sides. In other words, it's between the two sides. All right. So the rays of the angle are the two congruent sides. So let's look at an example here. So this first one, this is congruent by side angle side because we have a congruent side here, congruent side here, and the angle formed by those two congruent sides. So the one between the two angles are also congruent because they're both 90 degrees. All right. So that's why we can say they're congruent by side angle side. So since the angle is between the two sides, the triangles are congruent. All right. Now, this next example, still side angle side. Why is it still side angle side? It's similar to the previous one with SSS. So one more time. They're adjacent, meaning they share a side. So once again, these two triangles share a side, which happens to have the angle between the other congruent side. All right. So because they share a side, again, we can assume that it's congruent to itself. And we have the angle in between those two congruent sides. So once again, that would be side angle side. And just for a better reference, if I separated those triangles, just so you can see it a bit better, it's still the same thing. All right. Side angle side. Now, why can we not say that these two triangles are congruent by SAS? So if we use SAS specifically, why can we not prove that those two are congruent? Right, so the angles are kind of in different spots. So for example, this first one, we can easily say that's SAS because we have two congruent sides, the angles in between the two. But look at this one. Right, the angle's not between the two congruent sides. It's not formed by the two congruent sides. It's only connected to one of them. So because of this angle right here, it can't be SAS. We don't have enough information to prove that they're congruent. So it's not between the two sides, while this one is between the two sides. All right, so make sure you're paying attention to that whenever I'm saying, okay, I know this is going to be true by SAS. Is it or is it not true? It's all about the order and placement of the angles and sides. All right, we're almost done, guys. So sometimes we do have to make some assumptions, but they're usually assumptions that are, pretty obvious. All right. So the first assumption is the one that we've already talked about technically. You just didn't have a name for it. So when two triangles share a side, we can say that it's congruent to itself by the reflexive property. All right. So up top, like for example with this one, it shared a side. So by the reflexive property, we can assume that side is congruent to itself. All right, that's like the proper name for it. Then we have the third angle property, and all it says is if two pairs of corresponding angles are congruent, then we have to assume the third pair is congruent. All right, and why? Because, of course, the triangle sum theorem. All right, if we know that two sets of angles within two different triangles are congruent, we have to assume the third one is congruent to its corresponding self because of the triangle sum theorem. It has to add to 180. All right. Now, let me ask you this. If I know all three angles are congruent, but I don't know if any of the sides are congruent, can I assume congruency? No. Why? Think back to transformations. There was one that we did that created the same shape but different sizes. What was that? Dilations. So with dilations, we would create, say we were given a triangle, and then if we created a bigger version of that triangle because we dilated it. Still the exact same shape, meaning all the angles are exactly the same, but the sizes are not. All right, so just because we have three congruent angles, that does not mean that we can assume congruency. All right, just something to think about when we get further into it. The last assumption is vertical angles. So vertical angles are congruent. All right, other angle relationships could also be marked. So, for example, alternate interior. So, for example, sometimes, let's say we had a rectangle. Now, what do we know about a rectangle? Both sides, two sets of sides are congruent, but also they're also parallel. So we know that with a rectangle, it has two sets of parallel sides. Sometimes you'll see a triangle, two triangles cut between the two. So guess what? Let's say I marked these two angles. Are they congruent? Yeah, by what theorem? Not by postulates. I'm just asking if the two angles are congruent. You think those two angles that I marked are they congruent? Yeah, they are. By what parallel line theorem are they congruent? Not reflexive. The ones we learned yesterday. Alternate what? Interior. So you can almost imagine the rectangle as two parallel lines, and it's cut by that transversal. All right. Just something to think about because that may be thrown your way. All right. We can assume that those two angles are congruent because of what we know about alternate interior angles and parallel lines. All right. And once again, I already said this, but corresponding does not necessarily mean congruent. Only marked sides and angles can you justify as congruent. All right. So, like I said, innocent until proven guilty. We cannot prove it's congruent unless we have enough facts. All right. A triangle or a angle or a side cannot be guilty of being congruent unless we have enough evidence to prove otherwise. All right, so let's look at some of these examples. So, this first one on the left, which triangle congruency postulate, so SSS or SAS, do you think makes these two triangles congruent? SSS, why? Well, no angles marked, first off. There's nothing that we can do to prove otherwise. But why else? Because I only have two sides that are marked congruent. Right, they share a side, so we can assume by the reflexive property, it's SSS. What about the second one? SAS. Why? The angle's not marked, but what can we conclude? Right, let's see. The two angles C, so here and here, are congruent. Why? They're vertical. So these two angles are vertical. And since those two angles happen to be between our two congruent sides, it's SAS. All right, now, last one, and then we're done for today. So, what additional piece of information would be needed to prove that the triangles are congruent by SAS? So, given what I know about these two triangles, what would I need to show in order to say that they're congruent by SAS, side angle side? Right, we have to show that angle L is congruent to angle H, because those would be our two angles between our two congruent sides. So we would have to show that angle L is congruent to angle H. That's what we would need to prove. Now, what about if we want, using that same triangle, what if we wanted to show they were congruent by SSS? What would have to be true? Right, GI would have to be congruent to MK. All right. So we would have to show that GI is congruent to MK. That's what we would have to prove. All right. So sometimes, for example, if I asked you to tell me whether they were congruent by SAS or SSS, it's totally fine to tell me if there's not enough information. All right. Because that will happen occasionally. Like if I gave you this, but without the angles marked or the extra side marked, there's not enough information there to tell me whether it is or not. All right. Okay. So your homework tonight will be page 23. All right. It's pretty much doing exactly what we've been doing, just stating whether they're congruent and by what postulate. All right. Now, also, I have posted a 2.2 and 2.3 Delta Math. It's within the same Delta Math. All right. That'll be due Monday by midnight. All right. So, you guys got a solid 15-ish minutes. So, you can either work on the homework for tonight or you can work on the Delta Math. Let's say left. So that vocab sheet, if you want to glue it into your journal, let's say that goes on the left side of the next available page. Yes, sir. 23, yes. So basically the next page we have not done it. So guys, I will check pages 16, 17, and 23 tomorrow.